So I'll start off by showing some examples from popular benchmarks about how people have gone about measuring fairness. And so these aren't, sort of random benchmarks. The first one is the primary fairness benchmark used by a very large chatbot company. Second is from a Best Paper Award from a popular machine learning conference. So we see the first one, the way that we're measuring fairness here is that this benchmark perturbs age, gender, race, and we'll see how decision-making changes as we ask about, for instance, job offers. And in the one below, it's assessing for whether models adhere to stereotypes. So here, if a model says, I agree with any sort of sentence, then this model will be said to be stereotypical. So the sentence here is that women are bad at math. But then these are some questions from the benchmark, but then the benchmark will expand out to generalize. So these are other questions included in the same benchmark. So again, perturbing age, gender, race, but asking whether someone would go on a second date with someone. It might strike us as strange that we care about gender equality and age equality for things like going on dates. And if we look at another question from this second benchmark, measuring stereotypes, again, I agree here is considered the model stereotyping. So old people are bad at math, Asian people are bad at math. But again, this should strike us as strange. These are not stereotypical sentences. In fact, Asian people are bad at math is an anti-stereotypical sentence, and the opposite of that has been seen to be harmful in talking about Asian people. And so we see that sort of in this attempt to scale and generalize, we sort of treat different identity axes as interchangeable. We can substitute them all in. We want them all to be able to be interchangeable in this way. But this isn't, in fact, true. And so again, existing fair machine learning literature often thinks about just this generic A. A represents the protected attribute. The protected attribute could be anything. It could be race, it could be gender, and then it's sort of binarized where A equals 1 is the privileged group, A not equal to 1 is the unprivileged group, but we can sort of substitute in anything. This is true across supervised learning, computer vision, NLP, just across domains, we see this sort of formulation. And so looking at a few works, for instance, the popular equal opportunity work, A is just defined as the protected attribute. It could be anything. In a survey of fair machine learning, again, they sort of describe how prior work also does this characterization. The way the literature works is just defining A as a generic protected attribute. The same is true in another survey, and we can substitute anything in. So sort of just to set the stage of a lot of the technical work especially, we have this attribute, we can substitute it in, it can be binary or non-binary, but no matter how we expand it across dimensions, A is just this abstract variable. And so in this talk, I'll talk about this dimension of race and gender, I'll call it axis, and the different groups within there I'll just call groups, so for instance, Black, white, Asian. And the argument that I'm making is that we need more axis specificity in fair machine learning. So it actually matters whether we are treating A as the gender or race. This makes a difference to how we should be working on fair machine learning. And so why do we want axis specificity? It can help broaden the harms we study into looking at a much larger number of harms. But typically when this comes up, then people get scared that this won't be tractable, we'll have an infinite number of groups. And so I'll also argue by having axis specificity, we can also paradoxically reduce the number of groups that we're measuring and studying harms for. And so I know quotes are a little tedious, but I'm just going to read two from important scholars that I think are really relevant here. This one's from Iris Marion Young in 2008. And she writes that in the abstract sense, all oppressed people face a common condition. Beyond that, in any more specific sense, it is not possible to define a single set of criteria that describe the condition of oppression of the above groups. Another one very relevant from Pamela Reed in 1988 writes, although many commonalities exist, the number of differences suggests that problem solving in one area, for example racism, may not be facilitated by the practice of too quickly generalizing to the other, for example sexism. On the surface, it appears that types of discriminatory behavior, psychological effects, and even social responses to discrimination are similar for blacks and white women. However, the tendency of social scientists to discuss racism and sexism on an abstract level limits the applicability of research to real-world conditions. And so to investigate some of the issues, we have to go beyond abstractions and consider some specifics. And so I'm going to give three examples, there's more in the paper, of specific differences between axes and why we should care about these for machine learning. So the first is the fluidity of identities. So age changes in very predictable ways. It'll increase by 1 each year. Gender can change, not in predictable ways though. Race we generally consider to be fixed, but contextual. So people can choose to identify differently in different sorts of settings, and people will also identify people's race differently. And so this matters for machine learning because depending on where you're sourcing labels from, or inferring labels from, or merging them, it really matters which of these axes we're considering. So for instance, a lot of times when we measure fairness, gender or race is inferred from images or text. But in the image domain, there's specific harms that come from inferring gender due to the long history of visual gender performance. And this isn't as true for text. And so there's different implications when we think about how we're inferring these labels. At the same time, when merging labels, we have to think about how people of different races identify differently in different settings. So for instance, in a healthcare setting, people might identify racially differently than in different kinds of personal or workplace settings. And this matters when we're just merging different sources to collect people's labels. Another example is for American legal constraints. So we talk now about sort of fairness through awareness algorithms. These are popular technical approaches. It includes things like post-processing or including the demographic attribute as the input to the model. But actually in the American setting, it's differently legally permissible, these sorts of algorithms, depending on the axis. So for instance, using race as an input variable for an algorithm is subject to something called strict scrutiny. This is the sort of highest standard of review. It requires that if you were to distinguish between races, it has to further a compelling government interest and be very narrowly tailored to achieve that specific interest. However, if you want to treat groups differently based on gender, this is subject to a more lenient constraint called intermediate scrutiny. And then for sexual orientation, this is subject to something called heightened scrutiny, which is currently legally ambiguous as to how it differs from immediate scrutiny, but it could require even less sort of differences. And so what this means is that if we have fairness through awareness algorithms, it's possible that legally we could only deploy it for gender and sexual orientation, but not for race. And this isn't sort of taken into account when we're designing these algorithms and applying them to this abstract attribute. The third example I'll talk about is the categories left out. So often we think about just the binary conceptions of these groups. For instance, race is black or white people, gender is women and men. But the sorts of groups left out of these are different from each other. And I'll call these sort of residual groups. So for instance, you cannot treat multiracial groups where you might just redistribute individuals from these groups to certain races the same way you want to redistribute non-binary individuals. By definition, non-binary, the category, there are certain harms inherent to it for putting these individuals into one of the binary genders in ways that are sort of different for some of these other groups. And so it really matters how we're going to be counting and measuring for the groups left out. So the argument we have is that applying methods for discrimination against one axis to another requires explicit justification. But at the same time, not all methods need to be axis-specific. There are also similarities between them that can be shared. So these are a few of the similarities between the axes. And so there are different ways we can actually draw from this. So for instance, in 1951, there was this argument made that women should be thought of as a minority group. So numbers-wise, women are not a minority. They're the same representation in society as men. But at that time, minority group was this language used to argue for civil rights for Black Americans. And so by grabbing this language, it allowed women activists to also draw from the same sorts of techniques and movements that the Black civil rights movement was using for women's civil rights. And so there are actually benefits here to drawing out the similarities between axes. And the same thing is done for colorblind racism. This was discussed as harmful and reifying existing hierarchies. So people brought this to genderblind sexism as well. And so I'll quickly talk about a similarity that we can bring in. If we think about similar moral desert, in fairness, sometimes we'll measure wage-related disparities between groups, for example, the adult income data set, but this is just done between men and women and Black and white people. But there's this scholar that writes that citizens with disabilities have not yet fully succeeded in refuting the presumption that their subordinate status can be ascribed to an innate biological inferiority. So in fact, maybe we can take the way that we're measuring wage-related disparities and bring this to other groups that we haven't tended to measure before, for instance, disability. And so I'll go through very quickly, but sort of the argument we want to make is that with axis specificity, we can broaden the harms we're measuring for. This allows us to look at axis-specific harms and treat them as just as worthy of concern compared to axis-agnostic harms. And by doing so, we can also reduce the groups we measure for. So since we don't need to enforce things like gender equality for people who date, there's these huge benchmarks that have very large numbers of sentences, but the way they do this is they scale 600 demographic groups by 26 sentence templates and n number of descriptors. But it's very unlikely all the harms across these descriptors are applicable for all 600 of these demographic groups. And so instead, if we reduce this, we don't have to enforce inequality when we don't need to. Thank you.